Welcome back to God Maths. I hope you enjoyed our previous lessons. Today we will discuss the basic laws and properties of logarithms. Before we get started, remember to subscribe to this channel for more video lessons. Let's look at logarithms. Now if we have the logarithm of a number x to the base a, and that is equal to y, then this implies that, or it means that the number x is equal to the base a raised to the power y. This is the basic definition of logarithm. Now let's look at the laws of logarithm. The first law states that if we have a number, the log of a number x to the base a plus the log of a number y to the same base, which is a, then this can be expressed as the log of xy to the base a. So we multiply the two numbers and maintain the log to the base a. Then the second law is we have the log of x to the base a minus the log of y to the same base, then this can be expressed as we maintain log to the base a and then divide the two numbers. Then the third law, if we have the log of a number x to the power n to the base a, this can be expressed as n times the log of x to the base a. The power multiplies the log. So for an example, if we have log 2 to the base 6 added to log 3 to the base 6, then this can be expressed as log of 2 times 3 to the base 6 using the first law of logarithm. And then this will give us log 6 to the base 6. Then note that if we have the logarithm of a number to the base of the same number as log x to the base x, the answer is always equal to 1. So since we have log 6 to the base 6, we will say that the answer is 1. Then note also that if we have the log of a number without a base, then the base of that logarithm is 10. The log of a number without a base means log to the base 10 of that number. Let's take some other examples. So the first one, we have log to the base 7 of 49. How do we simplify this? The base can always give us a clue. How do we simplify 49 into 7? And we know that 49 is 7 times 7. So this will give us log of 7 squared to the base 7. Since 49 is 7 squared. And then from the third law of logarithm, we can say that this is equal to 2 log 7 to the base 7. And note one of the properties. When we have log of a number to the base of the same number, the answer is 1. And this will give us 2. Let's look at the second one, b. That gives us log 3 1 over 9. This can be expressed using the second law of logarithm as log 1 to the base 3 minus log 9 to the base 3. Check carefully from the second law of logarithm. And then from this we will have, there is another property which says that log 1 to any base is equal to 0. So there is another property there. We have 3 properties. And so we will say that log 1 to the base 3 is 0. Log 1 to any base is always 0. Minus 9 can be expressed in terms of 3 as 3 raised to the power 2 to the base 3. And this will give us 0 minus 2 log 3 to the base 3. Log 3 to the base 3 is 1 using this property. And that gives us 0 minus 2, which is equal to negative 2. We will take further examples which are more complex than this. Let's check them out. The first question, log 9 base 4 plus log 21 base 4 minus log 7 base 4. Note that the bases are the same, and so we can apply the first and second laws of logarithm. And that will give us this, using the addition law, will give us log to the base 4 9 times 21 minus log 7 to the base 4. The bases are still the same, so we can use the second law, which will give us 9 times 21 over 7, the same base. This is 3, and so we will have log 27 base 4. Note that 27 cannot be expressed in terms of 4, and so this is our simplest form. Otherwise, if the question requires in the decimal form, you use your calculator to get the value of this. Let's move to the second question. We are given log x base a equal to p, and then log y base a equal to q. And then we want to simplify this in terms of p and q. And this is equal to, using the first law, we can express this as and this will be equal to log x to the base a plus 2 log y to the base a. That is the third law of log. And then log x to the base a is p plus log y to the base a is q. So 2q. In our next lesson on logarithm, we will discuss more complex examples.